Hi everyone, today in this video we are going to solve the functions part from Pure Maths 3 P3. Now this is going to be a full revision video because this is going to be part 1 where we will solve all the functions question, and after this we will make another video for numerical methods and then again another for logs, trigonometry, integration, differentiation, all this type. Okay, so this is the first video of this series where we will solve all the chapter wise questions from P3. Now again in this video I'm going to solve questions from October 2022 to most probably the latest question papers that is available till now. And if you guys want to practice this type of chapter wise questions on your own, then you guys can purchase this our our worksheet for topic wise worksheet. Now this topic wise worksheet will contain question from 2014 to 2024, and obviously this will get updated, like as many papers as available they will always get updated. And if you are from Bangladesh, then you guys can purchase the hard copy of this book. We will deliver that to your home. But if you guys are from other countries, not from Bangladesh, maybe from Qatar, Kuwait or Dubai, then you guys can purchase this book from KDP. But we are still processing with the KDP everything, so most probably for this for internationals this book will be available by February, and for Bangladeshi people you guys can obviously purchase this from by the end of January or the start weeks of February. We'll obviously make a separate video for when these worksheets are available. And if you guys are interested to know more about this type of worksheets are obviously going to be made for P4, P1, P2, M1 and S1 and D1 and FP1 also. So if you guys are interested to make this type of worksheets more and more, then obviously we can do that more. And again, you guys have to request all these things in our WhatsApp number, and we will obviously try to communicate as fast as we can. So if you want to purchase, you guys can purchase that directly by February. And to get more informations about this worksheets, you can obviously WhatsApp us in our WhatsApp number. Hopefully that is visible already in the screen somewhere. And this is it. So let's start with this question. Now we're starting with functions. In this functions, we have maybe 7 to 8 questions which we are going to solve in this video. The first one is from October 22, question 2. Now this one says that function f and g are defined by these two equations, and it is also stated that first find out the range of fx. So for this range of fx, for this kind of equation, I do not actually understand how to find out the range from this type of equations. So what I will do is that, even though they're giving a very small marks, but you have to understand this very clearly. So I'm going to extend this maths a little bit in broad. So for part A, initially the question was given as 5 minus 4 over 3x plus 2. So I'm going to first simplify this equation. So if I want to simplify this, I'm going to write this as f of x. Do an LCM here obviously. Denominator will obviously be 3x plus 2. So I'm going to multiply 5 with 3x plus 2, which becomes 15x plus 30 minus 4. So again you get f of x 15x plus 26 divided by 3x plus 2, right? So this is how the equation looks like. Now in general, if I want to draw this graph, right, I would understand that this is a fraction graph, and it was already stated over here that domain is x is greater than equals to 5, right? Here the domain is greater than equals to 5. If the domain is greater than equals to 5, and I want to know that how at where the vertical asymptotes and horizontal asymptotes are. If I want to first find out the horizontal asymptote, HA is horizontal asymptote. Okay, now for horizontal asymptote, I always take horizontal asymptote cuts the y-axis, right? So for y-axis, we always take these two coordinates, which is 15 and 3, the coefficients of x's in this fraction equation. So this becomes 15 and 3. We're taking these two coefficients, right? For horizontal asymptote, this was always the case. I always convert the equation and write it as y is equals to ax plus b and then cx plus d. So when I'm working with horizontal asymptote, which is basically a y-axis asymptote, the equation for that y-axis equation will be a over c, and vertical asymptote is going to be cx plus d equals to 0, right? So now over here, from this 15 over 3, I get how much? 5. And for the vertical asymptote, this is actually an x-axis coordinate, which is going to be 3x plus 2 equals to 0 using this format. So you get c 3x plus 2, 0. And if you simplify this, you eventually get minus 2 by 3, which is in decimal, I think 0.6 something. So just 1 minute. Yeah, 0.67. So you get negative 0.67. Okay, then again, moving forward, I want to find out that where the graphs will intersect on the x-axis and y-axis. Understand that all these things were not required, but I'm just going to explain the entire process of how to find out the range for this kind of equations. So then again, if I want to find out that, when x equals to 0, where they're going to intersect with the y-axis and everything. So when x is equals to 0, f of 0 is actually going to be 26 over 3, right? Because 15 and 3, they are multiplied with x, and x is 0, so they will cancel each other out, and you will be left out with 26 over 2. So you get 13. And when you're considering that f of x equals to 0, like you're considering that this time y is 0. So when y is 0, this denominator will also become 0, because you're basically going to take this denominator to the right hand side or to the left hand side, and on the left hand side you already have 0. So multiplying anything to 0 converts that to 0. So you then eventually be left with 15 when x is equals to minus 26 over 15. And if you simplify this further, you will get 26 over 15, which is 1.73, negative 1.73. Okay, now if I want to draw this in the entire part, like how would the graph is supposed to look? The vertical asymptote over here was, which I was supposed to draw as a broken line. The vertical asymptote is at 0.767, and the horizontal asymptote is at 5. This is at 5, and then again we are going to plot graphs over here, right? I can understand that one coordinate is 13 and one is minus 1.3. I mean, this is 0, 13 and minus 1.73 and 0. So this is how the graph is going to be. This is how the shapes are of a fraction graphs, right? Very close to the asymptotes. And again, a similar shape will be created on the other other quadrant. This was your coordinate 13. This is your y is equals to 5, which was a horizontal asymptote. This is your x equals to minus 2 by 3. And this is your 26 over 15 negative, right? Now again, it was stated, wait, sorry, I actually draw the graph for negative, I think. No, it was minus 7.1.73, y is equals to 5, and sorry, I actually made a mistake. Over here, I was supposed to get 5 into 2 as 10. Just 1 minute. I'll correct this. This was supposed to be 10. If that's 10, then we're getting 6 here. And if this is 6, then this is going to be 6 over 15 actually. Right? And this is also going to be 15, 0. This is going to be 6 over 2. That is going to be 3. And this is going to be 6 over 15, which is 0.4. Negative 0.4 again. Minus 6 over 15, yeah, negative 0.4 and all. So that means this graph is actually going to be a little different. I was plotting the graph for your negative fraction, but this is a positive fraction graph. For this positive fraction graph, the graph is supposed to be like, it's going to create those kind of shape over here, and again another similar kind of shape over here, which is obviously going to be very close to the exact to these asymptotes, but will never intersect with the asymptotes. Okay, now in this case, I can see that obviously it intersects at 0.4. This vertical asymptote was at 0.7, right? This vertical asymptote was at negative 0.67, and this is your 0.4, negative 0.4. This is your positive 3. This is your y is equals to 5, right? All the informations we know. We have plotted that in the graph. And if you remember, In this question, the domain range was given within the values of x is greater than 0, greater than equals to 0. That means actually over here, I'm only focused on this portion of the graph, right? Even though we do have graphs on the negative axis, but we're not going to focus on that. We're actually focused on this portion of the graph. And within this portion, what I can see is that your range, like this range is starting from 3 and has to be smaller than 5, right? Because 5 is your vertical asymptote. It always has to be smaller than this value. That means in this case, the actual graph we're focused on is actually this portion. Sorry, 1 minute. If I delete this, we're actually focused on this portion of the graph only, which is in between 3 and 5, right? This is 3 on the y coordinate and this is 5 on the y coordinate. Your value for y is equals to 3 and your value for y has to be less than 5 because this was your horizontal asymptote and the graph never intersects with the horizontal asymptote. So over here, after all this work, now you can understand that your range in this case is supposed to be f of x less than 5 and greater than equals to 3, right? This is the range I was talking about in this maths, nothing else other than this. This is your important range, which between 3, greater than 3 and less than 5, greater than equals to 3 and less than 5, because 3 is actually a part of the graph as your domain starts from greater than equals to 0 and only less than 5 because your graph will never intersect with 5 as 5 was your horizontal asymptote equation. So this is it. All the works that you had to understand to get to this answer, right? To be honest, they're only giving you like this marks directly for the 2 marks. Like this much working is enough for the 2 marks. But in order to get there, you have to know all these works, right? You have to plot the sketch to understand that which range you are talking about over here. So this is it for part 2. After part A, then we'll move on to part B1. For B1, they are asking for the inverse function. For the inverse function, this is the basic thing we always do, right? I mean, for this one, since I have already did that conversion, that now f of x is actually 15x plus 6 over 3x plus 2, right? I know that f of x was written as like this format, 5 minus 4 over 3x plus 2. But I did the LCM, I did the simplification and wrote the f of x in a much more simpler single fraction, right? So you're going to use this. So you're going to write that let f of x be y, and we get y 15x plus 6 divided by 3x plus 2. So if I take the denominator to the right hand side, we get 3x plus 2y equals to 15x plus 6. Now taking all the x's to the right hand side, so we get 3xy minus 15x and then again 6 minus 2y, and similarly we're going to take 1 minute. Yeah, we can take 3x as a common factor. So from there we can write, or I'll write this as x 3, then we get y minus 5. Yeah, y minus 5, and there also I can take 3 as a common factor, which is going to be, oh no, I cannot take 3 as a common factor, so there's no point of doing this. 3y minus 15 and 6 minus 2y, right? So now after this, I'm just going to like keep x on the left hand side, and we get 6 minus 2y and your 3y minus 15, right? So this is how the equation is going to look. The problem is that this is in terms of y, but I was trying to find out f inverse x in terms of x. This is the inverse of the equation, but in terms of y. I want to find out the inverse of the equation in terms of x. That means what I just have to do is that replace y with x. Wherever in the equation I had written y previously, I will now write x over here, because now I just want to find out the inverse of the equation in terms of x and not in terms of y. So that's I'm going to replace this y with x over here, and this is it. This is everything you need to do for this maths. Okay, so we are done with your part B1. This was the working for your part B1. After this, if we move forward to your part B2, where they're saying that write down the domain of f inverse x. Now you have to understand this is one of the rules for your function, right? Where we know that this is the case. F in fx, when you're going to convert that into f inverse x, the domain over here, which was actually given as what? x greater than equals to 0, right, is going to be the range of this f inverse x. Okay, so this time you can write f of x, sorry, not just f of x, f inverse x greater than equals to 0, right? Domain was greater than equals to 0 in the inverse function. Now the range becomes greater than equals to 0. And this time for the original equation, range was what? You already calculated. F of x less than 5 greater than equals to 3. This was the working for your part A. So when you convert that into the inverse function, this now becomes the domain. And now domains are written as x less than 5 greater than equals to 3. This is your answer. That this time the domain is going to be 3 less than equals to x less than 5. And that is your answer. Right, no need to write this part over here or this part over here. You can just simply write domain is within 5 and 3, but I was explaining the entire process to you guys. So this is it for part 2. Again, we are done. After this, if we move on to your part C, this time this is a composite function, right? I have to insert gx into f, and this time also the value for x is given as negative pi. And gx is given as x by 3 pi by 6, x by 3 pi by 6, 4 sine x by 3 pi by 6. Okay, so if you're starting with your part C, where I know that I'm going to insert gx into f of x, where f of x was written as 15x plus 6 over 3x plus 2, and now I am going to insert insert gx into this equations wherever we have x. So we get f gx. So we have 15 4 sine pi by 3, sorry, x by 3 plus pi by 6 plus 6 divided by 3 4 sine x 3 plus pi by 6 plus 2. Only this was multiplied with 15 and only this function is multiplied with 3. So we now can replace this x also, because the value for x was also given as negative pi. So we can write negative pi here. Right, so now you can just clearly take everything like this into your calculator to get the value for this. Or if you want, you can obviously simplify this. For example, negative pi, obviously make sure that your calculator is in radian modes and never in degree mode. Whenever you're working with this sine function with pi values, this one becomes negative pi by 6, and 15 4 gives you 60. So you get 60 sine negative pi by 6 plus 6, and divided by 3 multiplied with 4 gives you 12. So you get 12 sine negative pi by 6 plus 2. And now after this, if you can write negative pi by 6, if you now calculate that value, how much is that? You get negative half. So now you have 60 negative half plus 6 over 12 negative half plus 6. So finally you can just write this is minus 30 plus 6, minus 30 plus 6 over minus 6 plus 6. Oh, wait, this one gives you, sorry, made a mistake. This was actually positive 2, right? So you get minus 60 with negative 0.5 plus 6 and 12, 0.5 plus 2. And that is actually, maybe I made a mistake somewhere, 1 minute. 15x plus 6, 3x plus 2, 4 sine pi by 3, negative pi by 3 plus pi by 6 is negative pi by 6. Sine negative pi by 6 is negative half. 60 and 3 into 4 is 12. Sorry guys, I actually forgot to see this absolute value function around the gx value, right? So all this time we are working with an absolute value, which means that there's actually have to be some modifications. So I will just erase this. Over here, what we can understand that I'm going to insert g negative pi into the f of x equation, right? So I'll just first simply calculate g negative pi modulus of this value again, 4 sine negative pi by 3 plus pi by 6, and then again this entire modulus. Inside this function I'm supposed to get -2, but after this modulus absolute value I always get a +2 value, right? So now I can say that okay, this time for g negative pi I'm actually considering this as f of 2, and now I can write 15 2 plus 6 over 3 2 plus 2, which is, by the way, how much? 36 over 6 plus 2 is 8, right? So 36 over 8, that is actually 9 by 2. So you get 9 over 2, and that is your final answer. Over here, this is the only rough work we did to calculate the value of your g negative pi separately, and then inserted that into the equation to get the value of your fg negative pi. And this is it. This is all the working you need to show for your maths from question 2, October 2022, P4 paper, P3 paper, sorry. Then if we move on to your next maths, this is for October 22 again, question 7. For this one, it says that the figure 3 shows a sketch of graph C1 with equations this. This is a modulus function again, or absolute value function again. Write down the coordinates of the vertex C1, intersection of C1 with the y-axis. That means we are trying to find out this coordinate and this coordinate, right? One thing to understand that this vertex over here cannot be 0, right? I mean, over here doesn't matter if it's the maximum vertex or the minimum vertex for any V-shaped graph. Always remember that this vertex actually comes from this value, okay, and the modulus over here, or the absolute value inside the modulus, can never be 0, right? Because yeah, on maximum this could be like any positive value, right? But 0 and negative is not possible, so we have to find out that specific value, that what is that value when this entire absolute value becomes 0. So we're going to find out the x coordinate first and then insert that into the fx equation to get the y coordinate again. So we are working with part A1, for which I already know that 3x minus 22 for the top vertex, or the bottom vertex also if I was working. This is always equals to 0. So in that case, I'm going to get how much? 22 over 3, right? So this is the x coordinate. That means after this, to find out the y coordinate, I just have to insert this into the equations, which is 5, 3, 22 by 3 minus 22 modulus. This one actually becomes 0. So we are anyway left out with 5. So the vertex coordinate is actually 22 over 3 and 5. This is the coordinate. And again, if I carry on with your part 2, where they're asking that where the C1 graph intersects with your y-axis. So for this, I want to find out this coordinate. For this y-axis, I already know that on y-axis, the value for your entire x-axis is always 0, right? So you can just write that, okay, on y-axis, x is 0. On that basis, if we try to solve this equation, y minus 3, 0 minus 22 inside the modulus function, I can understand that 3 multiplied with 0 will be 0. Minus 22 outside the absolute function was supposed to be 0, but after the absolute function also we have a minus sign. So it will be 5 minus 22 anyway, and you end up getting minus 17. And this is also true because you can also see that this point is actually on the negative y-axis. So it was supposed to have a negative value. So you get the y coordinate as 0. I mean this y-axis coordinate as 0 minus 17, right? So this is your part 1 and part 2. We are done with part A. After this, if you move on to your part B, find the x coordinates of the intersection of C1 with the x-axis. If I scroll up to your graph, I can see that there we are intersecting 2 times with the x-axis. Now obviously this happened because of the absolute value function, because originally maybe the graph was supposed to travel like this, but this portion was like created an image over here from the vertex because of the absolute function. We don't want a negative value for y, that's why. But now in this case, as we are working with this value, I want to find out the y coordinate, so x coordinate, when this graph is going to intersect with the x-axis, I exactly do not know that, this absolute function, this 3x minus 22 absolute function, if it was actually a positive value or a negative value, right? I don't actually have an idea of that. So that's why I'm going to consider this one, 3x minus 22, as positive ones, and then again 3x minus 22 as negative again. So I'm going to consider this one as positive and again as negative. And I have to find out, that when it's positive, when it's going to intersect with the x-axis, and when it's negative, then when it intersects with the x-axis. So we're going to solve the equation 2 times. I can again understand that, okay, on x-axis or at x-axis, the value for y is 0. If y is 0, then 5, the first equation was actually minus 3x minus 22, absolute function 0. If you're taking the positive function here, then this one will become minus, right? Because plus and minus will eventually make this entire function negative. So you have to work with 5 minus 3x, minus minus is positive 22, 0. So you end up getting 3x, and this is how much? 27, right? So you get the value for x as 9, right? 27 over 3 is 9. And then again doing the similar work, that this time we are taking 5 minus 3x minus 22, right? We are taking the minus version now, this one now over here. So minus and minus becomes positive. So now you're working with 5 plus 3x minus 22, 0. So this one actually becomes negative 17, and you get 3x 17. So x becomes 17 over 3, and these are the coordinates actually, 9 and 17 over 3. So you can just write down the coordinates separately, 9 and 0, and 17 over 3 and 0, right? So this is your coordinates finally, and that's it, nothing else to write over here. You can just write down that the coordinates are this, right? So this is it, nothing else to worry about here. After this was your part B. Then moving on to your part C. For part C, now they're seeing the diagram 1 on page 21. This is actually from the question paper, so contains a copy of a figure 3, and draw on the diagram 1, sketch the curve of C1 whose equation is this one, and you need to clearly identify any coordinates where the C2 is going to intersect over here. So for that I have to do some calculations, and then again scroll up to use the figure to draw this graph of 1 by 9 x square minus 9. So for part C now, your equation was given as curve 2. The equation was given as y 1 by 9 x square minus 9. I can clearly see that I can somehow use the a square minus b square equation into this, introduce the equation for this equation, introduce that formula for this equation. So we can write y 1 over 3x whole square and 3 whole square, right? So from there I can write 1 over 3x minus 3, and then again 1 over 3x plus 3, right? So this is your values for 1 over 3x, 1 over 3x plus 3, plus minus 3. That means now it will be easier for you to find out the coordinates. So if you work with that, when at x-axis y is 0, if y is 0, then you can write 1 over 3x minus 3, 0, and from there you get x equals to what? 9, and 1 minute, plus 3 minus 3 multiplied with 3, this is 9, and another value is 1 over 3x plus 3, 0, and then again this equation will give you minus 9, right? So these are your 2 points, and then again we can write at y axis when x is equals to 0, then again we can write that y 1 by 3, 0 minus 3, and 1 by 3, 0 plus 3, and from there again what we get, this 1 by 3 and 1 by 3 are actually cancelled out. You anyway are left out with minus 3 and plus 3, so which is going to give you a minus 9 value, right? So minus 9. So the coordinates that you get from this part of your calculations are, this coordinate is 9, 0, this coordinate is minus 9, 0, and this coordinate is, sorry, I made a mistake, this is minus 9, okay? See, this coordinate is 0, minus 9. So you have to, like, draw all of this into your graph. But other than that, from this equation, I can understand this is actually a quadratic equation, and this is a happy quadratic equation because the coefficient of x square is positive. So now if I scroll up, I can again, I already know that these vertices were also, like, 9 and 17 over 3. How much is 17 over 3 in fractions, so decimals? 17 over 3 is 5.7. So I already knew this was a 9, this was a 9, and this was a 5.7. Okay, so now if I want to draw a graph where this will also intersect at 9, so this is how the graph will be. But you have to obviously make sure that the graph is entirely symmetrical because you're drawing a quadratic equation, right? And this is your minus 9. This was not required, so just remove that. This is your minus 9. Okay, now we have drawn the graph for your minus, like, 1 over 9 x square minus 9. Now after this, I can see that obviously they're intersecting twice, right? Out of which this is a common point. 9, 0 is common for both the curve and this absolute value function, and we also have another intersecting point here. So now if I want to find out them, I think this is what they are going to ask you in part D, right? Yeah, find the coordinates of the point of intersections of C1 and C2. So that means I have to find out that specific point because I already understand there. This is one of the intersecting point already visible in the graph, and we want to find out the other graph over here, right? Other intersecting point over here. For the other intersecting point, I have to again, like, to carry on with the substitutions in this case. But in this situation, if you understand, like, this is a very important part of your calculation. Like, I want to find out the intersecting points, so I have to find out the intersecting points again with the same idea, that as your absolute value function was, as your straight line equation was given as an absolute value function, so we don't actually know that, which positive value or negative value I'm supposed to work with. So I'm going to work with both of them. This is the start of your part D. I'm going to obviously intersect C1 into C2. So eventually that will look like 5 minus plus 3x minus 22. And that is equals to your other equation was 1 over 9 x square plus 9, right? From there, if I simplified 5 plus, plus minus is going to be minus 3x minus 22, 1 over 9 x square. If I just make LCM over here, do the LCM over here in this side also, we get x square plus 81 divided by 9. And this time I already know how much I'm supposed to get, right? 17 minus 3x minus 17 minus 3x minus 17. So you take this 9 to the right hand side, to the left hand side, and you end up getting minus 3 with 9, and that is 27, and 17 with 9, that is 153, and x square plus 81. So if you take all of this thing to the right hand side, you get x square plus 27x and 81, 153, 81 plus 153, that is 2340. And then you can write 127, 234, which is, by the way, a math error situation here. This one doesn't give you any solution, so I won't get any solution from here. So if I have to then continue with the positive value, with the negative value, which is 3x minus 22, that is also equals to 1 by 9 x square minus plus 9. From there again do the same procedure, plus and plus will be plus, minus and minus will supposed to give you plus. 3x minus minus 22, wait, is it minus? Wait, I think I actually made a mistake over here. This was minus and minus will make this plus, and this will be 27 actually. Yeah, So this was supposed to be positive 27. Let me see if that creates any change. 9 multiplied with 27 is 243 over here, positive 243, and this is positive 27. That's fine, but you have 81 minus 243, and that will be minus 162. And then now if you do the middle term factorization, you get 127 and 162, 5.05, and this value is 1 minute. 5 and minus 3x, minus minus is going to be plus, so 22 plus 5 is 27. 9 3 27 negative, 27 9 is 243 positive, and 81 minus 243 is 162. And if we solve them, we are going to get roots from there also. I mean, you have to use the formula method this time. 1 minute. 127, 162, 127, negative 162. You get, the value for x is 5.05, and the other value for x is actually negative 32. We will decide that, which ones are we going to accept from here. Then this is it. After this, if you move on to this equation, again you get what? X squared plus 81 divided by 9. And this one will give you that minus 17 now. So you can write this directly, that minus 17. Then 27 and 17. 17 with 9 leaves you with 17 with 9 leaves you with 153, and x squared plus 81. So you get x squared minus 27, and 81 plus 153 is actually your 234 equals to 0, and you can now write your 1 minus 27, 234. This one gives you a negative I. Just 1 minute. Am I making any mistake? Sorry. You are supposed to get 3x minus 27 and 3x minus 27 and 3x. Yeah, 3x minus 3x plus 27 and 3x minus 17. There also I'm getting the same value, 3x minus 3x plus 27 and 3x minus 17, and that is always equals to your x squared plus 9. Was it plus 9 or minus? Okay, there I was making a mistake, sorry. It was supposed to be always x squared minus 81 minus this value. That's why the entire maths was not matching over here. If this is minus 81, so you get minus 81 minus 243. This one actually becomes 324 negative. And then you get 127, 324, for which you are supposed to get one as 9 and the other as minus 36. This is actually one of the values we already accepted, right? And then again after this, if you move on to this equation, this was minus 81. You take this to the other hand side, you get 81 and 153, which is actually of this value, but in the, 80 minus 81 plus 153 is going to give you 72, plus 72. And now if you do this factorization, 1 minus 27 and 72, then you get, from here you are going to get x equals to 24, and the other value is going to be x equals to 3. Now in this case, if you move forward to your graph, right, I can already see that this point is supposed to be what? Less than 5.7, and this is 9 already, right? So over here we cannot accept this value minus 36, because maybe if I was only focusing on the positive modulus, then only I would get this minus 36, but I was not following the positive modulus, right? This time I was following the absolute function, so I have to cancel this one. And again, this 24 has to be cancelled out because this is greater than 9. We're only accepting value for x that is less than 9, right? Or less than that 5.7. So your final solutions are, this I already know. The y coordinate of this is going to be 9. It's going to be 0. But we don't know the y coordinate of this value. So we have to find out the y coordinate for this value. So which becomes y 5 minus 3, 3 minus 22 modulus function, which is 9 minus 22. 9 minus 22 is 13. 5 minus 13 is actually minus 8. So you get minus 8 here. Finally, the intersecting points where you can say that intersecting first one was your 9 and 0, and the other one is your 3 and minus 8, right? So these are the solutions. This is it for your question part D, and we are done with your question 7. We are done with all the October 22 papers. I think this was October 22, right? Yeah. Then we'll quickly move on to the next part. This is from January 23. There also they're asking to find out the range, right? Now this is again in this format. For question 1, f of x is minus x square plus 9, right? They're giving you 1 mark. But from this minus x over here, I can understand that this is a sad shape graph. For sad shape, I always get a maximum point, okay? Another thing to understand that this is again not in the format of ax square plus bx plus c. This is in the format of ax square plus c, where c is actually the coordinate of your turning point, y coordinate of your turning point. So we got the value for your y coordinate of the turning point. Now if I want to draw this graph directly, this is how the graph is going to be. And this is your turning point 9, whatever the x coordinate is, that is not my concern. I was trying to find out the range, right? So I can see the maximum value the graph can have on the y-axis is 9. Other than that, the graph only steps downward, right? Moves downward. So this time the range over here for this graph is just going to be f of x less than equals to 9, right? Less than equals to 9. So that is your range. Other than that, nothing else to focus on over here. I'll just zoom out so that you guys can see this maths. I mean, this is a very common maths from your IGCSE Maths B also, right? Maths B functions, if you remember. This is it. F of x less than equals to 9. Now, if we move on to your next part. Yeah, no, that's not a problem. Now, if we move on to your next part, they're asking for what? G1.5 into the equation, right? In this type of equations, we have introduced one simple method from the previous question. I will first calculate G1.5, okay? So G1.5 is actually 3 to 1.5 plus 1. So you get 3 to 1.5 plus 1, and that is 0.75. So I'm just going to find out FG 1.5, right? That means wherever I have x into the equation of f of x, I'm going to insert the 0.75 now because g 1.5 is 0.75. So you get 9 0.75 whole square, and that is 9 0.75 whole square, which is 8.44. Okay. They didn't actually give any fractions, so they didn't give any decimals, so I should write this as a fractions, 135 as 16. This is your answer for part B. Then inverse of g, I already know how to do that. For part C, I'm going to say gx by, let gx be y, and in that case we get y 3 2x plus 1, taking the denominator to the left hand side, so you get 2xy plus y 3, and then you separately take every y to the right hand side, so you get 2xy 3 minus y, and finally you get x 3 minus y over 2x, right? And that is your equation for x. This is it for part A, B and C. We are done with your question 1 also. Now if we move on to your next question, this is from January 23, question 6. Okay, in this, again, they are doing the same thing, right? They have given you one function with absolute values, and they stated that inside the value we have an a, where a is a positive constant. This graph cuts the y-axis at point P, x-axis at point Q and R, and this top vertex as S. So we need to find out the coordinates of this P, Q, R, S, and in terms of A. First with P, I can understand that for P was on the y-axis, right? So at y-axis, your value for x is always 0. So in that case, you get y 3, 0 minus 5a absolute value minus 2a. So you get minus 5a minus 2a. So that means you basically have minus a minus 2a, which is, by the way, 3a, right? So this is your coordinate for P, 0 and 3a. Then again, after this, we want to find out the point Q and R, which was the x coordinate. So for part B, sorry, this was going to be part 2, and this is your part 1. So for part 2, we get at y-axis, sorry, at x-axis, your value for y is 0. If at x-axis y is 0, then you get 3x minus 5a, 2a equals to 0, and then again, taking this 2a to the right hand side, we have 3x minus 5a equals to 2a. If you take this to the right hand side, it becomes positive. So 3x, 2a plus 5a, which is basically 7a. So you get 7a, and finally you can say that x is 7 over 3a. Another thing, why did I stop writing using the absolute value? Because you have to understand that this absolute value was for the y-axis, that y can never be negative and all, right? But x can be negative and positive. That will not be a matter. That's why I removed the absolute value function. And then again, this is one of the values, right? You can think about it, actually, this is going to be a better way if I'm going to use a piecewise absolute function again. Just 1 minute. As it was already written that over here, your 3x minus 5a was inside the absolute function. That means obviously one of the version of this is going to be positive. It's positive 3x plus 5a, and the other version is going to be negative, right? 3x plus 5a. So now we did the calculation for your positive function, right? This is for the positive function, which was actually 1 minute, plus 3x minus 5a minus 2a equals to 0, right? So this was for the positive function, and now we have to carry on with this for the negative function as well. Just 1 minute. How many pages do we have? Okay, then we are going to work with the negative version again. So negative 3x minus 5a minus 2a, 0. From there we get minus 3x plus 5a minus 2a, 0. So now we have minus 3 again. So minus 3x, so plus 3, if we take that to the right hand side, we get minus 3. So x over here becomes 1a, right? So these are the coordinates of P and Q. Another thing, from your graph, you can understand that which one comes before which alphabet. Q comes before R. So 7 by 3 is actually greater than 1, I think. 7 by 3 is 2.33. That means this is obviously 7 by 3a, and this is your only a. So we can now write the coordinates of Q and R. This is for R, which is going to be 7 by 3a and 0, and this is for Q, which is just a and 0, right? So we are done with these coordinates. After this, again, they were asking you to find out the coordinate of the S, which was, by the way, the top vertex coordinate. We know at top vertex coordinate, always this modulus or absolute function is has to be like, always positive or greater than 0. So we're going to use that idea again. So for that, part 3, we are using that 3x minus 5a equals to 0, which eventually gives you the value 5a over 3. If the value for x is only 5a over 3, then y is going to be 3 5a by 3 minus 5a absolute function minus 2a. We can clearly see this 3 and 3 cancels out, 5a will be 0, so you get minus 2a for this. So for s, the coordinate is going to be 5a over 3 minus 2a again, right? So this is your solution for the s coordinate again. I will just separate the maths over here using a line. Okay, now we're done with your part A. This was part A 1, 2, 3. Now moving on to part B. For part B, I just have to solve this equation to find out the values of A, right? So then again, I have to work it as a piecewise function, because then again they are saying values of A. We are going to get multiple values of A. So we are going to start with this idea that what is given, 1 minute, x minus 2a, right? So x minus 2a is also a piecewise function now. So we're going to consider that, okay, plus 3x minus 5a minus 2a, and then again x minus 2a it was, so we're going to say plus x minus 2a. So you get 3x minus 5a minus 2a x minus 2a. I can see that this 2a and 2a cancels out. We're going to take this x to the right hand side, so we become 2x equals to 5a, and eventually you can write 5a over 2, and then again if you do this for the negative version, 5a minus 2a, and then again minus let's just use bracket over here, 3, and then again minus x minus 2a. This also becomes minus 3x plus 5a minus 2a and minus x plus 2a. So then again, if I understand that, no, we have how much? Minus 5 plus 5 minus 2 is 3, and this is 2. So you get 5a minus 2a minus 2a, and then again 3x minus x. So you have 4, so you basically have a here and 2x. So again, you're supposed to get how much? Half x here, right? So half a here. This is your half a. So one is 5 by a, 5a by 2, or a by 2 over here. So these are the solutions actually. That's it. Other than this, we cannot get anything from this. So we are done with this question of Jan 23, question 6. Moving on to the next question. This is from June 23, question 4. It says that function f is defined by this function. We have to find out the range, right? This is, I think, similar to the previous question we already solved. This is in the format of ax square plus, ax square plus c, where c is actually the coordinate, y coordinate of the turning point. So we get the coordinate, which is minus 5, and this is again a positive coefficient of x squared. That means this is a happy shade graph. Happy shaped graph always have the minimum point, right? So we get the coordinate, range as f of x greater than equals to minus 5, right? This is how roughly the graph is supposed to be. This is your minus 5, right? And your graph is always going higher than that value. That's why your range is always greater than equals to minus 5. This is it. Then after this, if we move on to your part B now, they're saying that on the following page, there's a diagram labeled diagram 1, which shows a sketch of the curve with the equation y is equals to fx. Now on the diagram 1, sketch the curve with the equation y is equals to f inverse x. We know that fx and f inverse x, they're always image of each other with the line y is equals to x, right? This is the y is equals to x. Sorry, 1 minute. This is the line for y is equals to x. So f of x is just going to create an image over here. So this is going to create an image on this part. But 1 minute, it's going to be like, little, yeah, like this. So that, they intersect at this point. They're going to intersect at that y is equals to x line. and then you have to remove that y is equals to x line because you're not supposed to draw that, okay? But roughly, in order to first create this image of f inverse x, you're supposed to write, draw the line of f of y is equals to x line, and then create the image of fx of as a f inverse x on this y is equals to x line, right? So this is it. I'm going to remove this now, and sorry, 1 minute. We're going to remove the y is equals to x line, and we're going to write this as, okay, what this is your y is equals to f inverse x, right? And that was it for your part 1. Say part B. After this, they are saying that y equals to fx meets the curve with equation inverse fx, and using algebra you have to just find out the x coordinate of this point P. That means this is your point P, and we're just trying to focus on this x coordinate of point P, not the y coordinate. So for this x coordinate, again, if I want to find this out, I just have to first have to have an equation for f inverse x, right? But we don't have that yet. So I have to first find out the equation for f inverse x. This is part C, and for that I'm going to first consider that let f of x be y. So if I'm going to consider f of x as y, then I can write this y 2x square minus 5. So from there I can get x as y plus 5 over 2, y plus 5 divided by 2, everything under the square root, right? So from there I get the equation for f inverse x as x plus 5 over 2 and everything under the square root function. Now if I substitute the two equations together, which is f of x and f inverse x, we get 2x square minus 5 and that x plus 5 to everything under the square root. Now if you're taking this x to the right hand side, you're going to have 4x power 4, then 4 with 5 is minus 20x square plus 25, and then again x plus 5 divided by 2. Taking this 2 to the right hand side again gives you, so to the left hand side gives you 8x power 4 minus 40 x square plus 50, and then again x plus 5, and again take everything to the left hand side. But 1 minute, this is x plus 5 and there you're getting x power 4, x power 2. That's quite big values to work with actually. Okay, now trying to solve in this way actually leads you to an equation like this. 8x power 4 minus 40 x square minus x, and 50 minus 5 is just going to be positive 45 equals to 0, right? So over here, if I want to solve this, I have to solve it like this. X power 4, 0x power 3, 40x square, and then minus x, and then plus 45, right? This is a very long equation to work with. Now, the easiest way in this case was supposed to be that in this situation, I know that at point P, y is equals to x is also there, right? So maybe your f of x was intersecting with that y is equals to x, or f inverse x was intersecting with your y is equals to x. So we can also use that idea that over here at point P, 3 lines or 3 graphs were actually intersecting. F of x, f inverse x, and your y is equals to x. So I can also write the other equation as, like, your equations is y is equals to x, then y is equals to 2x square minus 5, and then the other equation is the last one, which is x plus 5 over 2 square root, right? So in this way it will be easier to intersect them to find out the x coordinate. That means over here it really doesn't matter if you're using point P or your point whatever equation you are using. Are you using the equation for y is equals to x, or y is equals to this equation for this fx, or the equation for y is equals to inverse x, right? At the end, they're all intersecting at point P, so you can just substitute any of the equations together. So I'm going to use the easiest method, that I'm going to equation this equation 1 and equation 2 together. This is 3. So if I'm going to substitute 1 into 2, then we actually get 2x square minus 5 equals to x. From there we get 2x square minus x minus 5, 0. And I cannot do LCM, I mean factorize over here. From there I get how much? 1 minute. Sorry, the first one was actually minus 1 minus 5 and 2. So we get two values, 1 plus 41 root divided by 4, and then again 1 minus 41 root divided by 4. But in this equation, maybe it was stated, I mean, we can clearly see p is at the positive value, right? Not at the negative coordinate. So obviously, we're not going to accept the negative coordinate. We're only going to accept the positive value for this 1 plus root 41 over 4. And this is it. We are done with your part C also of this graph. Now, if we quickly move on to the next question, right? These are all the calculations we did for this question. If we move on to the next question, this is again from June 23, question 6 from the same paper with a different question. In most of the papers of P3, you guys are supposed to expect 2 questions of this function, okay? Now we have this f of x as a modulus. We are trying to find out the coordinates of P. I can see P is the top vertex, and at top vertex, this inside modulus is always what? Equals to 0. So we get x minus 2 equals to 0, for which the value for x is 0. So x is 2. If x is 2, then we're going to find out f2, which is going to be 3. 2 minus 2 minus 10. So this becomes 0. 3 with 0 is 0. So we just left out with minus 10. So the coordinate of P is 2 and minus 10, and that's it. Then after that, we have to do the inverse, I mean composite function of f0. So let's find out what is actually the value for f0 first. So part B, f0 is 3, 0 minus 2 minus 10. This is 6. I mean, 0 minus 2 is just 2. 2 with 3 is 6. 6 minus 10 is just minus 4, right? And now if you insert f0 into the equation, you get 3. f0 is minus 4, so you get minus 4 minus 2 minus 10. This is minus 6, right? Minus 6 outside the modulus is going to be positive 6. 6 with 3 is 18. 18 minus 10 is just 8, and that is it. So f0 is just 8 over there. Now after this you get C, solve the inequality. Now this is a very tricky question, even though in this case they're only giving you 2 marks, but you have to for solve this for the positive value and negative value, and then see for which inequalities this this line, I mean this modulus function is less than 5x plus 2. But for that, just give it for an idea, you can understand that 5x plus 10 is supposed to travel from this part, right? This is where the y is equals to 10 value is maybe, and 1 minute, 5x plus 10, right? So y coordinate is obviously 10, and when y is 0, x becomes minus 2, right? Yeah, this is how roughly the graph is supposed to be. Now after this, I'm going to find out that where they're going to intersect, right? And for a given inequality I'm working. So I'm going to write for part C, x minus 2 minus 10 less than 5x minus 10, right? For this, we already understand that this 3, I mean this, this x minus 2 inside the modulus, inside that absolute function, we have that as positive x minus 2, and again have that as negative x minus 2, right? Now for this, the positive x minus 2 and negative x minus 2, I can carry out with this as plus 3x minus 2 minus 10 less than 5x minus 10, and then again carry out the same thing as negative value also. So we're going to first focus on this plus value. So we get 3x minus 6 minus 10 less than 5x minus 10. So from there we can write how much? Minus 16 this is. So 3x minus 5x less than minus 10. If you take this, so this was plus 10 all the time, plus 10. If you take this 16 to the other hand side, it will be obviously added with the 10. So you get minus 2x less than 26, and after that you get x less than minus 13. Sorry, I think, yeah, in that case what happens? This will eventually become greater than minus 13, right? Because your inequalities have now changed. Okay, so we got one value here, that x greater than 13, right? Am I making any mistake? 1 minute. Minus 6, 10, minus 16, plus 16, and this is minus 2, so you're getting minus 13. Okay, this is one value. Now for the negative value, 3x minus 2 minus 10 less than 5x plus 10. Then again, if you carry on with your working, you're going to get what? Minus 3x plus 6 minus 10 less than 5x plus 10, right? So from there again, if you take all the x's together, minus 3x minus 5x, and this is, by the way, minus 4. You take this to the right hand side, you get 10 plus 4, right, which is going to be how much? 14. Then this is minus 8x less than 14, and finally you can get that this is again minus 8. It will get inverted as 7 by 4 negative, right? 18 over 8, 7, 14 over 8 actually leaves you with 7 by 4. Now these are the two inequalities. Now if you go back to your graph, we can see that, okay, they were like intersecting one point over here, and 1 minute, this was supposed to be positive 13 somehow, but I'm not getting that. No, I'm not going to get negative 13. My calculations are correct. Say positive 13. Answer is correct over here. But problem is that we're only going to accept this value and not the other value. The reason over here is that, in this case, originally the graph was supposed to travel like in this way, right? So on their pathway, they were again supposed to interact at some point, okay, which was supposed to be with that negative 13. So if you can extend this over here, right, and this line also, I'm just like going to make it like this. Right, so this is your another point of intersection. This was your another point of intersection, which is at the negative 13, right? Now you have to understand that we're only using this intersection when this modulus or absolute value function is less than this straight line, right? What you can see is that as we were referring to what? As we were referring to x greater than negative 13, for x greater than negative 13, this is your straight line, y is equals to 5x plus 10, and this is your absolute value function, right? X minus 2 minus 10. So after this x greater than minus 13, this is actually referring to this the opposite case, right? For which straight line is greater than absolute function. But over here I was working with straight line is greater than absolute function, but this is also giving me that maybe 1 minute. X equals less than, that will eventually give you to minus 13, but they are accepting this because in this case actually, like we're not supposed to consider that which one is above which graph, because in this case after the modulus function, when you introduce a modulus function, this equation was never supposed to travel down this much, right? They will just move upward and only intersect in this case. If I was not using the modulus function, then yes, they would intersect with this minus 13, but when I'm using the modulus function, they are intersecting at that negative 7 by 3, right? So problem is that if negative 7 by 3 means 7 by 4 you are taking, then 13 will not occur, because in that case you are accepting the fact that over here I was not working with the original equation, I was working with the absolute function of the equation. But if you're taking minus 13, then that means you're accepting that we're not working with the absolute function, this was another straight line and they will intersect at 13, right? So over here this is your hint that we're not going to accept this value. This is not equals to, and we're only going to accept this value, x greater than minus 7 over 2. So this is your final answer, right? So for this kind of equations, whenever they have given you inequalities for absolute function, even for 2 marks or very small marks, you should carry on with the working for positive absolute value function and negative absolute value function, and then see that if this range actually satisfy with your equation or not. For example, in this case, this was not satisfying with my equation, but this one did. So we're only accepting the 7 by 4 and not the 13. And then again after this, they're asking for if modulus of x equals to 0, right? This time not f of x is entirely modulus, this is modulus of x working here. So for modulus of x means that inside the equation for your part D, you had that f of x as 3x minus 2 minus 10, right? This time your x is also a modulus. If your x is also a modulus, that means you have to carry this for positive x and for negative x, right? So you have to say that this time x is either negative x or positive x. So you can write this time as 3. When again this time your fx actually doesn't have any modulus value, right? This time you're talking about f of x, like f of modulus of x. That means fx can be negative, like your y value can be negative, but your x value over here can never be negative. If that's the case, then in this case what happens? Over here, your entire function over here was supposed to be equals to 0. So you're going to write this equation as 3, 1 as positive x, so which is x minus 2 minus 10, 0. So you can get this as 10 positive divided by 3 plus 2. So eventually get x 10 by 3. 6 plus 10 is going to be 16, right? Then again carry out the same equation for your negative value for x. So you get minus x minus 2 minus 10, 0. And after this you get x 10 by 3. 10 by 3 and plus 2. So again you get minus x 16 by 3, and finally you can write x is equals to minus 16 by 3, right? So you get 1 as positive 16 by 3 and 1 as negative 16 by 3. And this is it. This is all the working you had to show for this question 6 of June 2023. So we are done with this question 6 of June 2023 also. Let's move on quickly to your next question. This is your October 2023 question 2. There again they're asking f of f6. That means f of f6 means I have to just insert f6 into the fx equation. So let's first calculate f6 separately. f6 is 6 plus 3 and 6 minus 4. 6 plus 3 is 9, 6 minus 4 is 2, so it's going to give you 9 over 2. And then again f6 means that over here instead of x I'm going to insert your 9 over 2 into the equations, right? This is it. Other than that, nothing else. And everywhere we have everywhere we have just x, we're going to insert 9 over 2. So you can write 9 over 2 is actually 4.5, 4.5 plus 3 and 4.5 minus 3. 4.5 plus 3 is just 7.5. 7.5 divided by 0.5. This is going to be how much? 1 minute. 0.5, that is actually 15 you get. 7.5 divided by 0.5 is 15. That is the final value for ff6. Now after this they're asking for f inverse. For f inverse also we know that we have to consider f of x be y. If f of x is y, then we can write y x plus 3 and x minus 4. So we can write xy minus 4y and then x plus 3. And then we can write all the x's together, xy minus x, 3 plus 4y. And again, we can take x as a common factor. We get y minus 1, 3 plus 4y. And we can write x, 3 plus 4y and y minus 1. This is again the inverse of the function, but in terms of x. And I was trying to find out the inverse of the function in terms of y. So in terms of y we calculated, but we want to find it in terms of x. So I just have to replace y with x. So we can write 3 plus 4x and x minus 1. And that is the solution for your part B. Then again after this, they're asking that gx is another function. And we want to find out the value for a. Exact value means your answer should be in the surds format, not into decimal. And this is the equation they have provided. GFA equals to 7. For that again, I'll first separately calculate how much is FA actually. So part C, if a is over here a plus 3 divided by a minus 4, I cannot simplify it any further, but I can insert this into your gx equation. So gfa is going to be a plus 3 and a minus 4 whole square plus 5, and that is equals to 7. So if you take this 5 to the right hand side, it will be equals to 2. And then on the left hand side, you're going to get a square plus 6a plus 9 divided by a square minus 8a plus 16 equals to 2. Now if you take the numerator to the right hand side, denominator to the right hand side, you get a square plus 6a plus 9 and 2a square minus 16a plus 32. And again, you take everything to the right hand side and flip the equation. So you get a square minus a is a square. Minus 16 minus 6 is going to be 22, right? Yeah, 22 minus 22 a. And 32 minus 9 is going to be 23. So you get plus 23 equals to 0. You cannot do your factorization over here. So if you simplify it, you're going to get values for a as 11 plus 2 root 7. So it's 7 root 2. And then again a negative value. But 1 minute. Let me just check. 1 minus 22 and then 23. Yeah, again a negative value, 11 minus 7 root 2. But for the negative value, this is actually 1.10005, which is exactly 1.1 we can accept. And for the positive value, which is actually 20.9 in decimals, this is 20.9. Even though I'm obviously not going to accept this negative, decimal values, but we have to accept one value of a, because in the question also it was stated find the exact value of a, not exact values of a, right? They're not accepting multiple values, they're only accepting one value from here. Okay, then if that's the case, no, we can accept both the values actually. So there's no point of to eliminate any one. Even though they were saying that, find the exact value for A, but it was not stated also anywhere in the question that A is a positive integer or something. But most probably if you insert this value, 11 minus 7 root 2 into any one of the equations, they will give you a, a random error values or something like that. For example, if you insert this value into this given equation, 11 minus 7 root, minus 7 root 2 plus 3 divided by 11 minus 7 root 2 minus 4, that gives you a minus root 2 value. If this is minus root 2, if you insert this into equation, then you get minus root 2 plus 3 and then again minus root 2 minus 4, everything under the square root plus 5, that leaves you with 5.05. If you insert this minus root 2 value into this equation, they will leave you with 5.08, which is not 7, right? Not even close to 7. But if you are going to insert this plus 7, 11 plus 7 root 2 plus 3 divided by 11 plus 7 root 2 minus 4, everything under a square, that is positive 2 plus 5 gives you the 7. So this is how the checking should be done, that if you insert this 11 minus 7 root 2 divided by 11 minus 7, so this is plus 3, 7 root 2 minus 4, you get 11 minus 7 root 2 plus 3, then again 11 minus 7 root 2 minus 4 and whole square that. No, sorry, this one also gives you positive 2. Positive 2 plus 7 gives you 5. X is a set of real numbers and x can never be equals to 4. So now actually, you have to accept both the values, right? Even though they were expecting find the exact value of x, but both of them actually leave you the same value for the situation. So we cannot accept any one value for the equation. We have to accept 11 minus 7 root 2 and 11 plus 7 root 2. So you're accepting both the values. So this is it for your question 2 of October 2023. After that, we will quickly move on to the next question, which is October 2023 question 9. From this question 9, it says that figure 2 shows a sketch of the curve with equation this value, where k is a constant. Given that the curve has asymptote at k, a and b are the coordinate axis. And first, we want to find out the value of this k. So for this value of k, one thing to understand that this is actually a shifted graph, right? Originally, your y maybe would look like ln x, right? And that was further shifted to your 1 minute, f of x was your y is equals to ln x, okay? And that was shifted to your it was multiplied with minus 4, so minus 4 if x plus 1 plus 2, right? This is how the entire graph shifted. Entire graph shifting over here was happening. So for your y is equals to ln x, right? If you understand that this inside part is actually getting shifted here, right? So for original graph, it was actually x equals to 0. For this time, it will be how much? X minus 1 always, right? For your horizontal translation of plus unit, always represent a minus translation. So there we always will get x equals to minus 1. So if x equals to minus 1, your value for k is also going to be minus 1. So you get value for k is equals to minus 1. From this translation stretching, we understood that. And for the y coordinate of a, x coordinate of b, we know what to do over here, right? So for the y coordinate, we know that at y axis, x is always 0. So we just have to do that part over here for part b. b1, that f0 we have to calculate. So we are using the equation 2 4 ln x plus 1. Okay, so 2 minus 4 ln 0 plus 1 and everything under the modulus. 0 plus 1 means it's ln 1. Ln 1 is 0 and 2 minus 0 is just 2. So your answer is just 2 over here, right? So your A is 2 0 coordinate. And then again for your part 2, your f of x is equals to 0, right? Because now your y-axis is 0. If this is 0, 2 minus 4 ln x plus 1, this is equals to 0. And for this one, you just have to you can understand that this time x can be 0. X can be both positive and negative, right? This modulus was only there to give you the idea that y-axis over here was never negative, right? So we can just solve the equation even without the modulus function. So you get 4 ln x plus 1 equals to 2. If you take this 4 to the right hand side, it will become half, and you get x plus 1 half. If you take the ln to the right hand side, it becomes x plus 1 equals to e to the power of half, and plus 1 to the other hand side becomes minus 1, right? So e power half minus 1, that is your solution. So for part B, you get e power half minus 1 and 0. This is your coordinate for part B. We are done with your part B2 also. After this, again, the similar case. We're supposed to work out with this inequality, right? This range greater than 0, values of x we're supposed to find out. So that means, again, similar thing. If I'm working with your... we have plenty of space, so we can start from here. If I'm working with your 2 minus 4 ln x plus 1 modulus function, that means over here we have minus x plus 1 and also another negative value, right? A positive and a negative value. 2 minus 4 ln x plus 1, right? Negative and positive. Now if I have to solve this, I obviously have to solve this with a positive value and with a negative value. So we have 2 minus 4 x plus 1. I'm working with a positive value. That was I think less than or greater than what? Greater than 3. So we get, if you take this to the right hand side, 3 minus 2 is going to be 1. So you get minus 4 ln x plus 1, 1. And then again after this, if you simplify this, you're supposed to get this as 1 by 4, right? So you get negative 1 by 4 actually, ln x plus 1 negative 1 by 4. Move the ln to the right hand side, it becomes x plus 1 e to the power of negative 1 by 4, and eventually you get x greater than negative 1 by 4 plus 1, right? Okay, now after this you can write the equation similarly with the negative version, which is going to be minus 2 plus 4 ln x plus 1 greater than 3. Take this 2 to the right hand side, it becomes 5. So 4 ln x plus 1 greater than 5, and then ln x plus 1 greater than 5 over 4, then x plus 1 greater than exponential 5 over 4, and finally you can write x greater than exponential 5 over 4 minus 1, right? So these are the two values of x over here. For these two values of x, we can write they're both separate from each other, but for this one, this is greater than equals to 5 over 3 minus 1. But for this one, actually, when we shifted that minus 4 to the right hand side, right? When we're shifting that minus 4 to the right hand side, this inequality was supposed to get shifted as less than this value. And if you're taking less than this value, we also have a limitation here. The limitation was minus 1, right? Because this was your asymptote. Whatever that less than value is, it can never be less than minus 1. So we can write the inequality for this one as a set of range, which is going to be x less than e power negative 1 by 4 plus, so this is actually minus 1, and then again less than minus 1, right? It always has to be greater than that value for k, and the other range is going to be x greater than e power negative 5 by 4 minus 1, right? So this is your final answer for this solution. After this, we don't have to work out for anything for this questions 9C. We are done with your question 9 from October 2023. So moving on to the next question, which is I think from January 24, question 1. It is stated that point P, which has coordinates minus 4 and minus 3, lies on the curve with equation y is equals to fx. Find the point P to which P is mapped when the curve is changed from fx to this transformed graph. This is normal simple translation, right? So for part A, f of x was transformed to f of 2x, right? That means x and y, all the coordinates for x and y will get transformed to half x and y, right? This is your horizontal translation with scale factor half. That means if the original coordinates were minus 4 and minus 3, they will get transformed to half multiplied with minus 4 is going to leave you with minus 2. So you get minus 2 minus 3, right? This is your part A. Then for part B, you have f of x transforming this to 3fx minus 1, right? 3fx minus 1. That means x and y will get transformed to your x minus 1 means x plus 1 for your x coordinates, and 3 means just 3y here. So all your minus 4 minus 3 will get transformed to minus 4 plus 1 is just going to be minus 3, and 3 minus 3 is just going to be minus 9, right? So this is it. Then again for your part C, y f of x modulus, right? Y f of x modulus means that this time all your y coordinates can never be negative. Understand that? Over here, x doesn't have a modulus. F of x, which is equals to y, they have an entire modulus. That means now your y coordinates can never be negative. Only your x coordinates can be negative. Okay. So this time all your y coordinates always have to be positive, and only your x coordinates is not a matter actually. X coordinate can be negative, can be positive. That is not a matter. That means over here, your minus 4 will remain as minus 4, whereas your minus 3 will now become positive 3. So you can write that, okay, f of x is changed to modulus of fx. So you can write that x and y will be changed to, x will remain as x and y will become the modulus now. So we have minus 4 and minus 3. So minus 4 will remain as minus 4, whereas minus 3 will become positive 3 now. So these are your answer for part A, B and C. So we are done also with your Jan 2014 question 1. Then moving on to the next question. This is from Jan 24 question 4. there we have to first work with a factorization, right? Like simplification. And then the function begins. So we have the equation as 2x squared minus 32 divided by 3x squared plus 7x minus 20 plus 8 by 3x minus 5. Okay, now for the denominator over here I can factorize this easily, right? So if I factorize this 1 minute, 3 7 minus 20, I get 5 by 3 and minus 4. 5 by 3 means I can work with 3x minus 5, and x minus 4 means I have to work with x plus 4, right? After this I can again take 2, so we get x squared minus 16 and then plus 3x minus 5. If I do the LCM now, I can see that we basically have 3x minus 5, 3x minus 5, and this one also can be broken down as 2x minus 4, x plus 4, and then on the denominator you have 3x minus 5, x plus 4 plus 8 divided by 3x minus 5, right? So now you can eliminate this x plus 4 and x plus 4 easily. So you can get x plus 4 elimination, and after this you get how much? I mean, if I do the LCM here, we basically have, I mean, you have like this 3x minus 5 and then x plus 4 and then again 3x minus 5, right? So if you take this 3x minus 5, you can get x plus 4 and 1. So you basically have the entire denominator, like, LCM as 3x minus 5 and x plus 4. If this is the case, so 2x minus 4 will remain like this, and your, oh wait, sorry, now made a mistake. Both of them have the same denominator, as x plus 4 is anyway cancelled. So you get how much? 2x minus 4 plus 8, sorry, not like this, 2x minus 8 plus 4 divided by 3x minus 5, right? Because they now both have the same denominator. I mean, this is how it looks like actually. X minus 4 divided by 3x minus 5, and then again 8 divided by 3x minus 5. Whenever they have two fractions with the same denominator, you can easily add the numerators together. So you get 8 and 8 cancels out. You eventually get 2x divided by 3x minus 5, and that is your final answer. Okay, so we're done with your part A, simplification of the two fractions. And after this, they are saying that show using calculus that f is decreasing function. You must make your reason clear over here. If it's a decreasing function or not, for that I have to first factorize this. For that factorization, I can understand I have to use a quotient rule this time. So for that, if I'm working with part B, where f of x is actually now 2x, 3x minus 5, that means now u is 2x, so your du by dx becomes 2, and v is 3x minus 5, so your dv by dx is actually just 3. Now if you introduce your f inverse x into the equation, so you have dv by dx multiplied with v with du by dx, so you get 2 3x minus 5 and minus u with dv by dx, so 2x and 3 divided by v squared, 3x minus 5 whole square. If you simplify this, it becomes how much? 6x minus 10 and then again 6x divided by 3x minus 5 whole square. Obviously this 6x cancels out, leaving you with minus 10 and 3x minus 5 whole square, right? So this is the expression for your fx that you get. Now in this case, it was stated that this is supposed to be a decreasing function, right? How can you know this is a decreasing function? Because in this case, your f inverse x is actually a negative value. So you can say that f inverse x is actually less than 0. Like whatever the value for x is over here, we have a minus negative in front, so you'll always get a negative value for fx. So we can write f inverse x is negative. If f inverse x is less than 0, that means obviously the function over here was a decreasing function. If it was greater than 0, if it was like positive over here, then you would say that f inverse x is greater than 0. So always your function is going to be increasing function. If it was equals to 0, then you'd say that your function is equals to 0, but this is always less than equals to or less than 0 or greater than 0. Another thing you can see that in this case 10 is a constant, but your 3x minus 5 whole square, right? This is always greater than 0. Anything with a positive power of 2, you'll always get a value greater than 0, right? If greater than 0, I mean if it is always greater than 0 for all values of x, in that case your f inverse x, which is minus 10 divided by something positive, like something positive value, both of them are positive. With the minus sign, you will always get a value of f inverse x as negative. So you have to write that this is minus 10 3x minus 5 whole square, and in that case we can write f inverse x is negative, I mean less than 0. Therefore fx is a decreasing function, right? This is the reasoning they were asking, that how do you know after the differentiation that fx is going to be a decreasing function? This is how we know. Since f inverse x is less than 0, so fx was actually a decreasing function. So this is it. We are done with your part B. Now moving on to part C. For part C, we're working with g inverse x, right? gx3 plus 2 ln x. So we have to do the inverse function. For that, C is going to be, we can consider let gx be y. So you get y 3 plus 2 ln x. So in that case, you get 2 ln x plus 3e, plus 3y. So you can write this as y plus 3, so minus 3. Then again, ln x is going to be y minus 3 divided by 2. So finally, you can write x is actually exponential y minus 3 divided by 2, right? After this, you can just write this as in terms of x. G inverse x is going to be exponential x minus 3 divided by 2, right? So this is your part C. After this, again, you can, I think what else? This is actually everything you should do for part C. Find the G inverse x. So after this, again, you can write, they are now asking for this solution, GFA equals to 5. Okay. So for that GFA equals to 5, I have to find out that was, I think, part D. So for part D, I have to find out FA first, right? FA is going to be 2A, then 3A minus 5. So your GFA equals to 5 will be, your gx was 3 plus 2 ln x. So it's going to be how much? 3 plus 2 ln 2a plus 3a minus 5 equals to 5. So you take this 3 to the right hand side, so you end up getting 2, right? So you can write 2 ln 2a 3a minus 5 equals to 2, and I can understand this 2 and this 2 cancels out, leaving you with 1. So if you take this ln to the right hand side, it becomes 2a 3a minus 5 with exponential power 1, and you take this 3a minus 5 to the right hand side, so you get 2a exponential, 3a exponential power 1 and then 5e power 1, right? If I want to find out the value for e power 1, how much is that? E power 1 is not a constant value, so we just have to take all the a's together, which is 2a minus 3a e power minus 1, or maybe take this to the right hand side and then this to the left hand side, so you get 3a e power 1, 2a, and then 5e power 1. We can also just write e over here because anything to the power of 1 is just that number. You take a as a common factor, so you get 3e minus 2, and then again 5e, so you get a as 5e, then 3e minus 2, right? So this is the solution for your part E, part A actually. over here they were asking for the exact value of a, so I'm not going to find out this into decimals or anything. So this one into decimals or anything. I'll just keep it like this, 5e 3e minus 2, not into decimals. This is the end for your Jan 24 question 4. This was part A, this was part B and C together, and finally this is your part D. After this, if we are moving, then we are moving to again Jan 24 question 8. In Jan 24, we have then in total how many? 3 questions from just functions so far. So I would say very lengthy questions here. So if you move on to your question 8 here, there it says that the graph figure 1 shows you this value, and in terms of a and b, where a is greater than b and a and b are both positive constants, find the maximum coordinates of the graph. Maximum coordinate of the graph means at this top vertex, and we all know at this top vertex inside of the modulus is always what? Equals to 0. So you can write a part 1 2x plus b, or minus b was it? 2x minus b, that is equals to 0. So your value for x becomes b by 2. If your value for x is b by 2, then your f of x is going to be a minus 2x minus b. So f b by 2 is going to be a minus 2b by 2 minus b modulus function. This is going to be what? 2 and 2 cancels out. B minus b is just 0. So you get a. So this is your maximum coordinate, right? Coordinate for the maximum point. So for this, it's going to be b by 2 and a. Then again, after this, we get how much? The coordinate of the point of intersection of the graph with y-axis. Y-axis, we know at y-axis, your graph is always going to intersect. The x coordinate is going to be 0 there. So you get y equals to 0. If y is equals to 0, then x is equals to 0, right? But because at y-axis x is 0. If x is 0, so we're going to find out f0, that is a minus 2 0 minus b modulus. So eventually get a minus b. So for your y at y-axis, the graph intersects at 0, a minus b. And then again for your part 3, we want to find out where the graph intersects with the x-axis, right? So at x-axis, your y is equals to 0. So f of x is equals to 0. If f of x is equals to 0, then I have to take the positive function and negative function there, right? Your 2x minus b modulus is actually a piecewise function. It could be either 2x minus b positive or 2x minus b negative, right? So if we consider this positive and negative separately, now we can write that plus 2x, the equation was a minus 2x minus b, that is equals to 0, so which is going to be minus, and minus is positive, so you get a plus 2x, this is plus minus, so it's going to be minus b 0, so you get 2x b minus a, and eventually x becomes b minus a over 2. This is one solution, and the other solution could be where we can consider that your a minus plus 2x minus b, that is equals to 0, and there again we get a minus 2x plus b equals to 0, so you get 2x equals to a plus b, and finally you can write this is your a plus b divided by 2. So the x-axis coordinates are b minus a over 2 and 0, and the other coordinate is a plus b over 2 and 0, right? So this is your part 1, 2 and 3. We are done with your coordinates calculation. Then after this, if we move on to your part B, where it is stated that on figure 24, on page 24, there's a diagram of figure 2 again, and on that you have to draw this graph, okay? Okay, part B is only this. You have to draw this graph only. What you can understand is that, I mean, this is actually a graph of y is equals to x minus 1, right? And that x minus 1, we have a modulus around x. That means all your negative x first will be, I mean, we're only focusing on your just what? Positive x-axis value, and that will begin reflected over the y-axis, right? Like this is how we actually draw the graph of y is equals to x minus 1. I'll first explain, and then we'll plot that on that shape. On general case, this was supposed to be only y is equals to x graph. Okay, this is how the graph started. This is your y is equals to x shape. Now after this, we are subtracting 1 from here. So when you're subtracting 1 from here, that means your graph is now going to intersect with the y-axis of minus 1. So your graph just got vertically translated with y-axis minus 1. This is your minus 1. Then again, when you are intersecting an absolute value around x, that means your x can be never negative. We are only accepting positive values for x. So we are going to only focus up to this. And again, it only doesn't mean this. This absolute values around x means that obviously we're working with only positive values for x, and only this part will again be reflected over the y-axis. Okay, so this entire thing is now reflected over the y-axis. So this is how the graph is going to look like. So whenever you're working with this type of equations, if modulus of x, that means you're only going to first draw x equals to or draw x greater than equals to 0 part of the graph, and then reflect that part. That means I'm talking about your x greater than equals to 0 part over y-axis. Okay, originally I only drew this part of the graph, right? Originally I only drew this part of the graph. That was your graph for representing y x minus 1, and then I reflected this part over the y-axis. That's why reflecting this part over the y-axis created this image. So you're going to draw this kind of V onto this shape. Okay, so this is how the graph is supposed to be, and this is your graph for y x minus 1, right? They have provided you in the question paper a separate set of graph. There only you have to draw that. On page 24 you will get that graph, right? But this is how the graph looks like. Okay, now we are done with your part B. For part C, now they are saying that this equation and this equation intersect at minus 3 and 5. So we have to find out the solutions of A and B this time. Okay, understand? Like over here we are trying to, don't have much space. We can work with this space also. We are working with this inequality, not just inequality equation, but with this modulus function, that modulus of x minus 1, this is equals to your a minus 2x minus b modulus, right? Now I do not know if the modulus was positive or negative, because both could be piecewise function. So if I take the positive values of x minus 1 and a plus 2x minus b, and then solve this equation, we get x minus 1, a plus minus is minus, so minus 2x minus minus is plus b, and from there I already know that over here they were intersecting at what values? 5 and minus 3 it was, right? So for 5 and minus 3, if I simplify this, if I take this to the right hand side, you get how much? Plus 2x, and then a plus b plus 1. So you get 3x, and then a plus b plus 1, and from there you can get x is equals to a plus b plus 1 divided by 3, right? But 1 minute. Yeah, let's just use this. X is equals to a plus b plus 1 divided by 3. And then again we can do the same equation with the negative modulus, which is going to be your same value, minus x minus 1, a minus minus 2x minus b, and then after this it's going to be minus x minus 1, minus minus is going to be positive, so a plus 2x minus plus minus is going to be negative b, and after this it's going to be how much? Minus a minus 2a, yeah, it's going to be minus 3x, and then again a minus b plus 1, and finally you can write that this time it's going to be a minus b plus 1 divided by minus 3. But then again, I'm not getting any equation solutions from here, but they did give you the informations that, you know, they were intersecting and the solutions for x were minus 3 and 5. I can understand that they would get 5 here and minus 3 on this section. That means this is your minus, actually we have a minus value in front of the modulus also. That means this modulus also got reflected over the x-axis, right? So in this case, it was this if this was 5, then the positive value was supposed to give me the 5 solution, right? The negative was supposed to give me the 5 solution, and the positive was supposed to give me the, like, you know, minus 3 solution. So if I can insert, 1 minute, minus 3 here, it's going to be like, you know, from there I'm going to get a solution here. Like if I'm going to get minus 3 here, then I'm going to get minus 9. Take this one to the right hand side. We're going to get a plus b equals to minus 8. And from there also, if I insert 5, it's going to be 15. Minus 15 minus 1 is just going to be how much? Minus 15, 1 minute. This is minus x minus 1 plus 2x. So if you take this to the right hand side, it's going to be positive 15. Okay, I think we actually made a mistake here. That's why I was not getting the answers in this case. In this situation, this is how the graph for your, like, you know, absolute value original graph would look like. This is how the graph was. Now for this graph, if you can understand that they are actually inversions of each other, right? If they are inversions of each other, that means over here, this graph, if this is positive, this is going to be negative, and if this is positive, this is going to be negative, right? So you have to work with the opposite cases. Sorry. Okay, just 1 minute. If I then write down the equation, that means over here, if I'm taking this as negative, this has to be positive, right? So that is the case. So we get minus x minus 1 minus 2x plus b. From there, take all the x's together first. So this one is going to be minus 1 plus 2 is just going to be x, and then x minus 1 a plus b, right? The value for x over here is going to be like, maybe if you can take 3. Okay, no, sorry, I was doing the first correct thing, that if this is negative, this is also supposed to be negative. Then from there we can get minus 3 minus 1 a minus b, and from there we get a minus b equals to 8, right? We're supposed to take that, you know, if one is negative, then the other is also negative. Then after that, positive x minus 1, and then again a minus plus 2x minus b, and then again after this you get what, x minus 1, and then a plus minus is going to be negative 2x, minus minus is going to be plus b, and then again x minus 1 and plus 2x and a plus b. So you get 3x minus 1 a plus b. If now we consider the value for x as 5, so you get 15 minus 1, which is just going to be 14, or we can write a plus b equals to 14. Now if you, like, you know, arrange the equations together, that is a plus b equals to 14 and a minus b equals to 8, I can see a and a cancels out. So b and b cancels out here, and you get how much? If b and b automatically cancels out, you get 2a, and 14 plus 8 is 22. So you get the value for A as 11. If A is 11, you just have to substitute this into any one of the equations. So I'll substitute A11 into this equation, okay? This is B 14 minus 11 and that gives you 3. So the value for A is 11, B is 3. And this is it. We are done with your, this is which question? Jan 2014, so Jan 24, question 8. So we're done with, I think, all the questions from Jan 24. We will then move on to your June 24 questions. June 24 question 1. So in this question, they have given you this graph for which the equation is this. Find the coordinate of P. P is the top vertex or the bottom vertex, right? We know at the minimum point your inside the modulus is 0. So you get x minus 5 equals to 0, for which you get x equals to 5. And for the y coordinate, you try to find out f5 then, right? So 2, 5 minus 5 modulus plus 10, which is going to be 0 into 2 is 0. Plus 10 is going to be just 10. So you get the coordinate of P as 5 and 10. After this, use algebra to solve this inequality. Again, you have to carry on with the positive value and with the negative value. So you can understand that for part B, plus 2x minus 5 plus 10 greater than 6x, it's going to be 2x minus 10 plus 10 greater than 6x. So now 10 and 10 cancels out. You are left out with what? Minus 4x less than 0. So this will actually be a 0 value over here. Like you get greater than 0 actually, because you have a minus 4. So you get, sorry, less than 0. The inequality will get inverted. The negative equation is going to be 2x minus 5 plus 10 greater than 6x. From there you get minus 2x plus 10 plus 10 greater than 6x, which is going to be, if you take this 6 also to the left hand side, you get minus 8x greater than minus 20. So you get x less than 20 by 8, which is going to be how much? 5 by 2, right? So you get x less than 5 by 2. Now, somewhere in the equation, we have to understand that we have one coordinate as 2.5 and then again another as 0. So in this case, the equation was what? 6x, right? Y is equals to 6x. For y is equals to 6x, that means this is how the coordinate was supposed to be. This is how the y is equals to 6's graph is going to pass by. Why? How do I know it's going to pass by origin? You can just substitute that when x is equals to 0, y will also be 0. So now this actually have two coordinates, because if you did not do the modulus over here, then this graph was supposed to pass over the origin also, right? But in actual life, this graph would never, I mean, for this question, this graph will never be able to pass over the origin because we use the modulus function here, right? So for that modulus function, this portion was got this portion before, after this point P, this portion over here got inverted as this section, So that's why after this portion got inverted onto this section, then only you got the point as 5 over 2. So we're only going to accept that 5 over 2 value or not, and not that 0 value here. So this is again your similar question like we did in the previous part. So you're only going to accept this value, not this value. And then after this, find the point to which P is mapped when the graph with the equation f of x is transformed to the graph of this value. Again, a simple transformation, right? 3fx minus 2. So part C is f of x is getting transformed to 3f x minus 2. That means in general case, all the x and y coordinates will get transferred to x plus 2 as we have a minus 2. So your horizontal translation will be plus 2 units to the right and 3y. So your coordinates for P were actually 5 and 10. So 5 and 10. That will get modified to 5 plus 2 is 7 and 3 with 10 is going to be 30. right? So this is your value. We're done with your question 1 also, question 1 of June 24. Then we'll quickly move on to the next question. This is your June 24 question 5. There they have given you fx and gx. They're trying to find out f inverse 22. For that, I have to obviously find out the coordinate or equation for f inverse first, right? So for that equation for f inverse, we have 5. F inverse, we will write that equation that let fx be y. From there, I can write down the equation y, 2 plus 5 ln x. And from there, we get how much? 5 ln x, y minus 2. And x will eventually become exponential y minus 2 over 5. So f inverse x is just going to be exponential x minus 2 over 5. And then again after this, I was trying to find out f inverse 22. So you have 22 minus 2 over 5, right? So this is what I was trying to calculate. 22 minus 2 is 20. 20 divided by 5 is 4. So your f inverse 22 is actually e to the power of 4, right? Nothing other than this. This is your solution. So we're done with part A also. Then again, they're asking that use differentiation to prove that g is an increasing function, for which I have to first differentiate the equation, right? So I can understand that here this is your u value and this is your v value. So we get u as 6x minus 2. So your du by dx here is going to be 6. And v is 2x plus 1. So your dv by dx is going to be 2. Now your f prime x, g prime x is v with du by dx. So that's 6, 2x plus 1 and minus 2, 6x minus 2, right? E with dv by dx divided by 2x plus 1. After this, if you simplify this, you get 12x plus 6 and 12x plus 4. After this, 2x plus 1 whole square, 12x cancels out, 6 plus 4 is just going to be 10. So you get 10, 2x plus 1 whole square, right? Again, now you can understand that 2x plus 1 whole square is positive for all values of x, right? And which makes your g prime x greater than 0. If g prime x is greater than 0, then obviously your gx is always increasing. So therefore, you can say that gx is always increasing, right? This is it. Then after this, find out the range of fgx. For fgx, I would first have to find out the equation for your fgx, right? Oh, sorry, before that, we are working with g inverse x for part C. For part C, g inverse x means that gx be y. So we basically have y, then 6x plus 2, and then 2x plus 1. So if you take that 2x plus 1 to the right hand side, we get 2xy plus y and then 6x plus 2. You take all the x's together. So 2xy minus 6x and then 2 minus y. And from there, take x as a common factor, 2y minus 6 and 2 minus y. Then x will become 2 minus y and then 2 minus 6. And finally, you can write that yes, you have g inverse x as 2 minus x and 2x minus 6, right? So this is your equation. Wait 1 minute. So 6x minus 2, that was, sorry. If that was minus 2, then this is minus 2. Then this is minus 2, minus 2, minus 2, minus 2, right? Yeah. Then this is your final answer. Now for that f g x, I have to first find out the equation, right? So your part D was f g x. That means for f it was 2 plus how much? Sorry, forgot the equation. 2 plus 5 ln x. So it will be 2 plus 5 ln x. Now inside x I have to insert the value for gx, right? But 1 minute. Find the range of fg it was just. I actually don't understand that the range of fg, by that what do they mean? Just 1 minute, maybe there was some problem with the question paper or something. Let me check and then come. Okay, in this equation actually I was not supposed to find the f of fgx over here. I'm just going to find out the fgx is range, but not actually find out the equation. Like we don't have to find out the expression for fgx. So if I start with f over here, that was 2 plus 5 ln x, and it was stated somewhere here that x 1 minute, the domain of this was x greater than 0. Okay, x greater than 0. And why is x greater than 0? Because you have to understand that for your ln x graph, this is how the ln x graphs looks like, right? This is how it will look like for your x is equals to 0, it will never intersect with the x equals to 0, right? It will always go beyond the continue with the y-axis, negative y-axis. So we can say it can just continue for negative infinity. And then again after this, if your gx equation, for your gx equation, it was 6x minus 2 and then 2x plus 1, right? 2x plus 1. It was stated that over here your x will be, like for this question, it was stated that x will be greater than 1 by 3. But from this equation, it will be very difficult to find out the, range of this case. But from your g inverse x, I can easily find out the domain, which is what? X can never be 3, right? If I insert x equals to 3, your entire equation will be math error. So for your g inverse x, I get the domain as, and again on the value for your x, that also cannot be 0. If the value for x is 0, no, not x is 0. We can accept x is 0 over here, because for x is 0, then we get 1 by 3, right? So over here we get that your domain is x less than 3. If your domain is x less than 3, that means your g inverse domain is x less than 3. That means domain for, sorry, not domain, range for g, range for your gx over here is going to be less than 3, right? So this is the range for gx less than 3, and one range that we also get for your f, right? That your f over here can not be equals to your infinity value. Like whenever your x is greater than, like x is equals to 0, then your fx is also minus infinity. Then you can write that, okay, over here your fx is greater than infinity, and your domain for the range is less than 3. Like for gx is less than 3. If gx is less than 3, then if you insert 3 into the equation, right, fg 3, right, we are considering that gx, like the value for gx is equals to 3, right? You can answer fgx equals to 3. That means whatever the equation was, 6x minus 2, 2x plus 3, that is equals to now 3. So we can write fgx is, if that is equals to 3, so you get, right, what, 2 plus 5 ln. Instead of writing all these values, I'm going to insert 3 over here. And according to your range, if gx is less than 3, fgx is also going to be less than this inequality. And again, if fx is great less than, is it less than? No, it's going to be greater than minus infinity. That means over here, your fg is also greater than minus infinity. So over here from this part, I should have written this down, that we understand that when your x is equals to 0, your value for fx will always continue towards the negative y-axis. So you'll always have a value minus infinity. So you get fx greater than minus infinity. and your gx less than 3. So insert that into the equation. So now you can write the in range of fgx, which is going to be, or you can write fg as the equation was stating in this format, less than, as gx was less than 3, so fg will also be less than this expression, 2 plus 5 ln 3, and as fx was greater than minus infinity, so fx will be greater than minus infinity. So this is your range for this equation, right? So this is the solution for your part D. After this, we are actually done with all the questions from your recent paper, October 2020, to the recent paper from functions. Okay, so we're done with the functions topic. And after this, we'll start with the numerical methods. And that will be a second part of this equation, of this type of files, or of this type of videos. And if you guys are interested, please inbox us for this worksheet booklet, for if you are looking for this type of questions, of topic wise questions, as PDF or as hard books. Most probably the PDFs will not be available for the topic wise booklets. You guys will have to purchase the hard copy for the topic wise booklet. And again, if you guys are interested to buy this worksheet also, that is from October 2022 to the recent paper, you guys can purchase the unsolved file of this worksheet, or also the solved file of this worksheet, for which you guys will have to contact me through my WhatsApp. The number is obviously written over here in the screen, or if you do not know my number, then you guys can go to the Edexcel Easy About section to get my number there. Thank you for watching.